The Dodge Charger name has long been associated with the muscle car era. Rear-wheel drive cars with tire smoke and performance and head-turning looks. With the return of rear-wheel drive, Dodge is bringing the Charger back, this time combining Hemi power with advanced systems. Welcome to the March Mastertech. This month, we're going to start off with a brief look at the newest addition to the Chrysler Group, the Dodge Charger. We'll cover the model lineup, the features that Charger shares with other 2006 LX models, and some differences. Then, we'll bring you up to date with recent changes to climate control systems, including features of the systems on new models, things you need to be aware of concerning diagnostic and service procedures, and current service concerns. We'll begin our look at Charger with a rundown of the model lineup and standard powertrains. The SE is equipped with a 2.7-liter V6 engine and 42 RLE transmissions, and SXT models equipped with a 3.5-liter high-output V6 engine and the NAG1 transmission with auto stick. Charger RT models are equipped with the 5.7-liter Hemi V8 with MDS and the NAG1 with auto stick. Look for additional Charger models, including one equipped for police work and performance versions, to be covered in future Mastertech releases. The powertrains in Charger have some changes which will be adopted on other LX models for the 2006 model year. These include refinement to the accessory drive on 2.7-liter and 3.5-liter engines, aimed at further reducing NVH. The 2.7-liter and 42 RLE also get an interactive coast down feature that results in smoother shifts. Along with the features which Charger shares with other 2006 LX models, there are a few features that set it apart, such as Charger's styling. Charger uses all new upper body sheet metal, as well as all new side and back glass. Note that unlike the Chrysler 300, the Charger trunk lid is equipped with a key cylinder. For 2006, Charger and other LX models will offer a feature which was the subject of a recent Mastertech program, tire pressure monitoring. Charger TPM is the same as the base non-magnet train system used on 2005 Grand Cherokee and Liberty. An indicator is used to warn drivers that one or more tires are low. Inside Charger and other 2006 LX models, you'll find another new feature, an optional DVD vehicle entertainment system mounted in the center console. Rear seat occupants can control the system via a remote control or buttons on the front of the player. But there is also a lockout switch on the unit which allows front seat occupants to disable the player. Like the overhead systems on Durango and Grand Cherokee, the vehicle entertainment system is connected to the vehicle's audio system through the CAN bus. This allows the audio and DVD systems to operate with one another or independently. Some features help give Charger its own identity. Take the suspension, for example. It's the same basic design as on other LX models, but it's tuned to meet the requirements of the Charger models. SE and SXT models feature a touring suspension that balances ride and handling. The suspension on RT models moves a little further along the handling side of the equation with a blend of touring and performance. The available Road Track Performance Group offers the most responsive handling of the three suspensions. Self-leveling shock absorbers on the rear suspension are included in the Road Track Performance Group. Just as on the Chrysler 300 and Dodge Magnum, the rear-wheel drive design and near-equal front-to-rear weight distribution contribute to Charger's outstanding handling. That's supplemented by four-wheel anti-lock brakes with traction control and electronic stability program. All standard equipment with 3.5 and 5.7-liter applications. Well, that does it for our look at the 2006 Dodge Charger. Next, we'll bring you up to date on recent developments in climate control systems. Climate control is one of those topics that makes its appearance every so often on Mastertech, and with good reason. New models often result in new climate control systems, and the diagnostic and service procedures for both new and existing systems undergo revisions that you need to be aware of. We covered some of the features of the new systems briefly in New Model Highlights programs. Now, however, it's time to take a closer look at what's new on some recently introduced models. Before we get into individual systems, we need to revisit a feature mentioned before on Mastertech because it is common to all new systems, the downstream evaporator temperature sensor. Moving the sensor downstream in the housing from the evaporator fins makes it easier to test the sensor. It also reduces the chance of damage to the evaporator fins during sensor removal and installation. The Chrysler 300, Dodge Magnum, Dodge Charger, and 2005 Grand Cherokee have climate control systems that are similar enough that we can discuss them together. Systems include a manual temperature control single zone system and an automatic temperature control dual zone system. In both cases, the control head manages most HVAC functions. By the way, you should never exchange control heads from one vehicle to another. Differences in software can result in improper HVAC system operation. The ATC system allows for both manual and automatic control of most HVAC functions. For automatic comfort control, the ATC uses an infrared sensor in the control head to sense approximate body temperature of the front seat occupants, and dual sun sensors housed in a single unit on the instrument panel to sense sun load. The way these systems manage compressor clutch operation may be a little different from what you're used to and deserves a closer look. On ATC systems, the control head sends a message over the CAN-B bus to the front control module. The front control module then sends a message over the CAN-C bus to the powertrain control module, which controls the compressor clutch. On MTC systems, the control head sends a multiplexed input to the cabin compartment node, which sends a message over the CAN-B bus to the front control module. The FCM then sends a message over the CAN-C bus to the powertrain control module. Both ATC and MTC control heads monitor systems while they're operating and can store trouble codes if they detect faults. The system tests in the diagnostic procedures are another means of fault detection. In fact, running the test is the only way to obtain some of the diagnostic trouble codes used in troubleshooting the systems. Initiating these tests and retrieving trouble codes is not the same on ATC and MTC systems on these vehicles. ATC systems are on the CAN-B bus, and you can use the star scan to conduct tests and read trouble codes, as well as for other diagnostic functions. MTC systems, on the other hand, are not on the bus, and you need to use the control head to read trouble codes and conduct tests. The procedure for retrieving trouble codes on an MTC system actually involves two stages. The first checks the LEDs in the control head to make sure they can display trouble codes properly. And the second is used to display any trouble codes the system has recorded. To initiate the LED check on this Dodge Magnum, after turning the ignition on, turn the blower motor control on. Press the AC switch down and turn the blower motor control off. All the LEDs should illuminate. To retrieve trouble codes on this Magnum MTC system, turn the blower motor control on. Press the AC switch down and turn the blower control off. Then wait 5 seconds and release the AC switch. The LEDs will illuminate for 5 seconds, and then the AC indicator LED will begin displaying trouble codes, if any are present. Long flashes of the LED indicate the first digit of the trouble code, while short flashes indicate the second digit. For example, here the trouble code is 34. Note that the EBL LED is illuminated for stored codes, but not for active codes. The control head displays trouble codes in ascending numerical order and will start over after displaying all codes. If the control head LEDs fail to light up or display trouble codes, you can use the procedure AC heater control will not enter diagnostic mode on Tech Connect. That procedure and those used to investigate the trouble codes are located under the Service Info tab. To start system calibration on the Magnum MTC system, after turning the ignition on, turn the blower motor to off, and then press the heated vac light switch down. Hold it down for 5 seconds and release it. We'll talk more about calibration and other system tests later when we discuss what's new in diagnostic procedures. The 2005 Dodge Dakota is another recently introduced model, and the climate control system on it is worth a closer look. The Dakota uses a new single-zone manual temperature control system. The control head is responsible for managing HVAC system functions. However, this manual temperature control system is on the CAN-B bus, and you can use the star scan to diagnose it. Not all changes to the HVAC systems have occurred on newly introduced models. For 2005, Chrysler Sebring Sedan, Sebring Convertible are available with an automatic temperature control system. The system is similar to the LHATC system that was covered in the May 2002 Mastertech. Like that system, the ATC control heads on the Sebring are connected to the body control module via the bus. The BCM is hardwired to blend, mode, and recirc door actuators, as well as the blower motor power module. And just as on LHATC, the system uses 5-wire actuators. 2 of the wires operate the door motor, and 3 provide the BCM with information about door position. Another change on Sebring Sedan, Sebring Convertible for 2005 is the use of a new blower motor resistor for manual temperature control systems. A resistor block now provides blower control, and it replaces the solid-state credit card type used previously. A version of this resistor block has been developed for use in 2001 through 2004 applications. See this month's reference book for the part number. When it comes to diagnosing HVAC systems on the newer models, you're going to notice some similarities in the approach used. We've seen that some diagnosis results from tests initiated either with the control head or with the star scan. These individual tests are part of a larger overall procedure referred to as the HVAC system test that begins the diagnostic procedures. The entire procedure can be used as an overall check of system function, or individual tests can be used for specific symptoms. The AC system performance test, or cool-down test, monitors the drop in evaporator temperature while AC is operating. If the test fails, you need to investigate any trouble codes that result. When using the test, be sure to observe all the test conditions in the diagnostic information, or you may cause the test to fail. Once initiated, the cool-down test runs automatically. However, another test in the HVAC system test requires that you position controls manually. Positioning the controls according to the test instructions methodically checks control head circuits. Once again, you need to investigate any resulting trouble codes. The final test in the system test has more than one use during HVAC service. The actuator calibration test can be used to check HVAC system actuator door travel. Once again, this test is automatic once it is initiated, and you'll need to investigate any trouble codes it generates. The other use of the calibration test is to reestablish actuator limits following component replacement. Remember that in some cases, running the diagnostic tests is the only way to generate certain trouble codes. Not all of the changes in HVAC diagnosis are the result of new models. For example, recently, the test used to determine whether an AC system has the correct amount of refrigerant was revised. You can use the revised partial charge test as a general indication of whether a system has the correct charge. You might use this test after an AC performance test indicates that the system is not operating as it should. To ensure accurate results, you'll need the proper tools, which include a manifold gauge set or charging station for high side pressure readings, and a digital thermometer with a clamp-on thermocouple probe for liquid line temperature. You'll also need to follow the test steps carefully. It's particularly important to place the thermocouple probe on a clean section of the liquid line as close to the condenser as possible. Where the high side pressure and liquid line temperature fall on the test chart will indicate whether the amount of refrigerant is the problem. For example, if the test results fall into the undercharged area on the chart, your next step might be to check the system for leaks. Remember that the partial charge test procedures may vary according to application, so be sure to see the service information for the vehicle you're checking. At this point in our AC update, let's turn our attention to some current service concerns that you need to be aware of. You're probably aware of the contamination that can occur from the use of aftermarket refrigerants. That's why it's important to determine the type of refrigerant in a system using an identifier such as one available from PSE. However, there is another contaminant that a refrigerant identifier cannot detect, and that's refrigerant system sealant. Sealants are becoming increasingly common in AC systems. In fact, some cans marketed to do-it-yourselfers even contain sealant along with the refrigerant. The problem with sealant occurs when it enters a recovery recycling machine and clogs passages, and the warranty for most units is void if sealant contamination occurs. To protect your AC equipment, it's a good idea to check with customers to see if system contamination might have occurred, and to use available refrigerant identifiers and sealant detectors to check out suspect systems. Our final service concern involves Service Bulletin 2400404 that addresses compressor failure on certain minivans. As always, be sure to read the bulletin carefully to make sure it applies to the vehicle you're working on. Then, be sure to follow all the procedures so that system contamination or excess refrigerant oil does not shorten the life of the new compressor. The procedures in the bulletin are extensive, but they are necessary to help avoid comebacks. Well, that's all we have time for this month, so be sure to join us next month when the subject will be recent changes to bus communication. Thanks for watching.